Hi guys, welcome to our first video on calculus. In today's video we'll be looking at limits, and we'll also be looking a bit on first principles, so finding the derivative using first principles. Now our first method of finding the limit is using direct substitution, and this is the easiest method. Now it's important to note that calculus is built on the idea of limits. Alright, so it's only fitting that we start off with limits. So what we want to do is we want to find the limit of that function there. So the limit of 3x squared plus 4x minus 1 as x tends to negative 2. Now to do this, all we do is we simply replace our negative 2, or x's, sorry, with negative 2. And that gives us 3 times negative 2 squared plus 4 times negative 2 minus 1. And we can solve that, and here we'll see that the limit is 3. Now what this is saying is that this function here, 3x squared plus 4x minus 1, as x goes closer and closer to negative 2, this function approaches 3. So the y value would approach 3, or f of x, if we call the function f of x, would approach 3. So that's the idea of the limit there. Let's look at another example. So we want to find the limit of 3x plus 1 divided by x minus 1 as x tends to 5. Once again, through direct substitution, we find this limit to be equal to 4. So we replace the x's with 5, and when we simplify, and we get 4. So here the limit is equal to 4. Now it isn't always possible for us to find the limit using the direct method or direct substitution method, so we have other methods for finding the limits. One is the factorization method. Now let's say we wanted to find the limit as x tends to 3 of x squared plus 5x plus 6 divided by x plus 3. Now if we applied the direct substitution, that would give us 0 divided by 0. So substituting negative 3, x as negative 3 would cause the numerator to be equal to 0 and the denominator to be equal to 0. Now this is very important. This form, we call this the indeterminate form. Now whenever we were finding a limit and we get an indeterminate form, it is an indication, or is usually an indication, that we need to apply some other method for evaluating the limit. So here we factorize. We realize that x squared plus 5x plus 6, that is a quadratic, and we factorize. So factorizing that gives us x plus 3 times x plus 2. So we now have x plus 3 times x plus 2 divided by x plus 3. And if you notice, these guys here, we can cancel. So all we'll be left with is the limit of x plus 2 as x approaches negative 3. So now we're able to apply our direct substitution, and that gives us negative 3 plus 2, which is equal to negative 1. Now something I should point out is that you realize that each time when we make the substitution, we substitute the x for whatever value is here, you realize that we no longer write this limit. Alright, so whenever you make the substitution, you stop writing the limit. Alright, so let's look at another example. So similarly, if we want to find the limit of x minus 5 divided by x squared minus 25 as x tends to 5, if we apply direct substitution, we have 0 divided by 0, which, as you remember, I said that this is the indeterminate form. So clearly we're able to factorize x squared minus 25. So that gives us x plus 5 times x minus 5. Alright, and we're going to divide x minus 5 by that. Once again, we have things that can cancel, and that leaves us with 1 divided by x plus 5. We can now apply our direct substitution method, and that gives us 1 divided by 10. So here the limit is 1/10. So as for this function, as x approaches 5, the function will approach 1/10 or 1/10. So as the x values get closer and closer to 5, so remember the x value is on the x-axis, right? So as the x values go closer and closer to 5, whether you're going from the left or from the right, the function will approach 1/10. So f of x will approach 1/10, or y, the corresponding y coordinate, y value, would approach 1/10. So we also have the conjugate method. So the conjugate method, we usually use this when we have square roots. So similarly, let's say we want to find the limit of x minus 25 divided by root x minus 5 as x tends to 25. If we were to apply direct substitution right off the bat, we would have 0 divided by 0, so we have the indeterminate form. So what we need to do is we need to apply the conjugate method. Now here we look at the part that contains the square root and write the conjugate. So if you're, for those of you who remember surds, so we write the conjugate. So here we have square root of x minus 5, so the conjugate is square root of x plus 5. So we change this sign here. So if this was a plus, we'd have a minus here, and since we have a minus, it's going to be a plus. Now we're going to multiply by the conjugate over the conjugate. Now root x plus 5 divided by root x plus 5, that's just 1. So it means that we aren't changing what we have, we're just basically rewriting it. Now there's a trick to using the conjugate method. What we're going to do is the part that we have multiplying the conjugate of, we're going to actually expand that part, while the other part here we're going to just write them as a product. So we're going to put them in brackets and put them beside each other. So that would give us something like that. So that's a trick that you need to remember. Alright, you only, when using the conjugate method, the only part that you expand is when you're multiplying the surd by its conjugate. That's the only part you expand. The other part, like here in the numerator, you would leave them as products of each other. So clearly now you'll see that we can cancel x minus 25, and that leaves us with root x plus 5. So taking the limit as x tends to 25 gives us 10. So here the limit is 10. So having looked at how we evaluate limits, we can now turn our attention to finding derivatives from first principles. Now to find a derivative from first principle, what we're actually going to do is we're going to find the limit. So the derivative, which is represented as f prime of x, alright, is equal to the limit as h tends to 0 of f of x plus h minus f of x divided by h. So all we need to do is to find that limit and we'll have the derivative. So let's say f of x is equal to 3x squared plus 4x, and we want to find the derivative. What we need to do is we have f of x, so we need to find f of x plus h. Now f of x plus h, we replace our x's with x plus h, is 3 times x plus h squared, because remember replace the x with x plus h, so it's 3 times x plus h squared plus 4 times x plus h. And we can expand, and expanding gives us that guy there. So now it's just a matter of substituting in the formula for the first principles. Alright, so f prime of x is equal to the limit as h tends to 0. So we have f of x plus h. Now f of x plus h is this guy here, sorry about that, minus f of x, and notice to put them in brackets, divided by h. It's usually good to put them in brackets, especially the f of x, because this minus here needs to be distributed If you don't, you might leave it and say minus 3x squared plus 4x and not distribute the minus. Alright, so simplifying gives 6xh plus 3h squared plus 4h. Now if you note here, if we substitute h as 0, we get indeterminate form. So that means we can't use the direct substitution method as yet. Any idea what we can use? Well, we can use the factorization method. We can factor out h from the numerator, and clearly the h from the numerator will cancel that in the denominator, so all we're left with is that there. Then doing our direct substitution, we get f prime of x to be equal to 6x plus 4. So the derivative of 3x squared plus 4x is 6x plus 4. Let's look at a more interesting example. So remember, that is how the derivative is defined. I want to find the derivative of the square root of x. So similarly as before, we have f of x plus h, which is just the square root of x plus h. So remember, replace the x with x plus h. Then plug in that in our formula. We have the square root of x plus h minus the square root of x divided by h. Now remember, our aim here is to find the limit. Now if we substitute h as 0, once again we have indeterminate form. Now which method do you think we need to use to evaluate this limit? Clearly it is the conjugate method. Once you see the square root, automatically your mind should go to the conjugate method. So we're going to multiply by the conjugate of root x plus h minus root x. So remember, we simply change the sign between them. Alright, and remember, there's a little trick when dealing with the conjugate method. You only expand the part where you're multiplying by the conjugate, by the third and its conjugate. So that means we're going to expand the numerator, and the denominator we're going to just keep it as a product. Doing so gives us x plus h minus x divided by h times the root of x plus h plus the root of x. Clearly x plus h minus x, x's will cancel, so we're left with that guy. And I think you should be able to see now that the h's will cancel, and that will leave us with the limit as h tends to 0 of 1 divided by the square root of x plus h plus the square root of x. Now we're able to apply the limit, so we'll have 1 divided by the square root of x plus the square root of x, so that's just 1 divided by 2 root x. So the derivative for root x is 1 divided by 2 root x. And that's it for today's video.